You might recall back in chapter 3 of the preliminary course, functions and their graphs, I think it was, that you looked at the exponential. Well, you looked at exponential functions. So you looked at 2 to the x and 3 to the x and the variations. So you have seen what the graph actually looks like. Back there, we didn't actually talk about the exponential. We didn't talk about this number 2.718, is it? 2.718. We didn't talk about that back then because chapter 3, we hadn't learned how to differentiate and we weren't focusing on it. But now that we've learned to differentiate and we're going to develop more methods by which we differentiate. So that's why we're looking at this particular exponential, because this is the exponential that we can differentiate. We also need to be able to graph this particular one. So it's not, I know that you know how to graph y equals 2 to the x and y equals 3 to the x, but you also need to be able to graph y equals e to the x. Y equals, for example, e to the x. So the more familiar you are with the graph, the easier it is for you. So some features of the graph are the domain is all values of x, and just like I'd spoken about that in the previous video, the curve is always above the x-axis for y equals e to the x. Once we start introducing some negatives, things change and it goes below the x-axis. There are no zeros. That is, the curve does not cut the x-axis. As x approaches negative infinity, y is getting closer and closer to naught, or the x-axis, but it never gets to it. The negative x-axis is a horizontal asymptote, and the opposite end, as x approaches infinity, y approaches infinity as well. The curve has gradient 1 at its y-intercept, so that is unique to this value, 2.718 blah 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 blah, to the x. The curve is always concave up. What does that tell you about the sign of the second derivative? Is the second derivative always positive? If it's always a positive, then the curve is always concave up. So just some practice for you to sketch y is equal to e to the x. You need to use e to the x on your calculator, which is above the ln button, and that's on the sharp calculator. So you practice that. I will pause the video and get my calculator, and let's see if we get the same values and the same curve. So hopefully we've all got the same numbers in our table of values, and of course you use your calculator, and then graphing them, we're getting this exponential curve shape that we would expect. Of course then you do have transformations of these, so we saw this also back in the preliminary course. Moving the graph up and down the y-axis means you will add to or subtract a constant from the actual function. Really this is just revision. Moving acrossways, you impact directly on the x, and a positive number being added moves it to the left. And the reflections in the axis, reflecting in the y-axis, you then get y equals e to the x, and in the x-axis, y equals negative e to the x. So you can do these examples out of 2b.